Hello and welcome to the Chandara Academy. In today's video we are going to solve two logarithm equations. So this is a method you have to know how to use. We'll see it both times. This is a method of change of variables. So each time we are going to set capital X is equal to log in some base of little x, and we are going to solve some easy equation in capital X. So let's start with the first one. Log 3 of x everything squared minus log 3 of x to the third. So this is the x to the third power plus 2 is equal to 0. We want to have an equation. Here we see we have some log 3 to the second power. Here we have some log 3, but we have a x to the third inside. So this is a problem, but we can easily put it in front of the log. So we will have a log of x, and here we will have a constant. So this is a simple polynomial of order 2. So let's try to solve it and transform everything to get into some powers of log 3. So log 3 of x everything squared minus 3 log 3 of x, because let's remember that log of a to the b is equal to b times log a, and here we have a is equal to x and b is equal to 3 plus 2 is equal to 0. And if we see that here we have 2 times the same thing inside of the logarithm, we can let's set x is equal to log 3 of little x. And this gives us the equation capital X squared minus 3 capital X plus 2 is equal to 0. And we know how to solve this kind of equations. So delta is equal to b squared. So minus 3 squared, 9 minus 4 times 2 is equal to 1. Two solutions. x1 is equal to minus 3, so 3 minus delta, square root of delta, so minus 1 divided by 2. And x2 is equal to 3 plus square root of delta, so 1 divided by 2 times 1, so 2 times what's in front here, it's equal to 1 is equal to 2. And now that we have solved this equation, we are going to solve back the equation x is equal to log 3 of little x, because we want to find the solution for little x. So the equation for the first capital X, x1 is equal to log 3 of little x1. Okay, the x1 associated with this one. And we have 1 is equal to log 3 of x1. And this is equivalent, we know it, to x1 is equal to 3 to the 1's power is equal to 3. So first solution. If we do the same thing for the other one, so for x2, we will have 2 is equal to log 3 of little x2. And this thing is equivalent to x2 is equal to 3 to the second power is equal to 9. And we have two solutions for little x, which was the question. We've got 3 and 9. We are just going to plug them back into the equation and to verify that we don't have any problem. So here, if I plug in 3 and 9, this thing is greater than 0, so this is okay. Same thing for the x to the third power. And so these are the two solutions. Now second equation. We've got log x plus 1 over log x. I remind you that log without any base is the log in base 10 is equal to 2. When we are given the equation like that, and because we are dividing by log x, of course, log x will be different from 0, and x, which means that x will be different from 1. And what can we do when we have log x different from 0? We can keep the same equation just by multiplying by log x. And we will have log squared of x plus 1 is equal to 2 log x. And we can do this thing because and only because log x is different from 0. Let's put everything on the same side. Log squared of x minus 2 log of x plus 1 is equal to 0. Same thing as before. Let's define capital X as log of x, because we have the same thing here and here. Just here this is squared and here not. And then we have a constant. So this means that the equation becomes x squared minus 2x plus 1 is equal to 0. This is equivalent to x minus 1 squared is equal to 0, which means that capital X is equal to 0, is equal to 1, is equal to 1, sorry. And now let's solve. Capital X is equal to 1 is equal to log of little x. And we know that this thing, because log is log in base 10, is equivalent to x is equal to 10 to the 1's power, to the first power. And this thing is equal to 10. And our solution is x is equal to 10. Is this okay with the equation? Yes, because when x is equal to 10, we've got the thing inside the log is greater than 0, and this thing greater than 0 and different from 1, because we do not want to divide by 0. And we have solved the whole exercise. Hope you enjoyed the video. See you soon. Bye.